Hello and welcome to the video guys. So today in this video we are going to cover all the easy questions of maths of the FRAS Leetcode DSS sheet. So this is all the questions that we are going to cover in this video. Let's start the video. So we are going to cover the question number 1 of here, which is reverse the integer. So reversing the integer, how to do it in the maths question of Leetcode question number 7. So let's try. So I would reset it to the form that it was previously in, defining the reverse and the 32-bit sign integer range. I have to define the range. So int mean, that is the range, the minimum range. Excuse me. Int max will be equals to this. The question says that the range should be between minus to the power 31 to the power 31 minus 1. So we will assign the range. We know that the power is given in coding like the two stars asterisk. Here we have a similar thing with us, how to increase the font size, format the code, and okay, okay. So the size is set, and this one is to the power 31 minus 1. We're doing it in Python because in Python it's easier to code and the code is quite shorter than we do in C or C++. It's case sensitive, so we have to do it accordingly. Sign equals to minus 1 if x less than 0. So we have to reverse the number. If x equals to 1 to 3, then output will be 3 to 1. So by that logic, we have if x else it will work with the absolute value of x. If x is less than 0, then we have to return it as something which is not defined here, because we have to work with the absolute value of x. Then x would be multiplied with the sign. X multiplied with the sign equals to the sign x equals to x multiplied with the sign. Initialize the reverse number to 0. So the reversed x would be assigned to 0. It will be initialized. And then we have to make a loop while x, so that we can get the last digit and add it to the reverse number. So the reversed number, that is reversed x, equals to reversed. This is the whole number, but we have to store the number in something different, and the same number is stored back into that. So the number, the reversed x, is initialized to 0. It will start from 0, and while it's x, so the number will be initialized, and it's multiplied with 10, and then what's added into it? The simple logic of adding the remainder, so that when it's divided by 10, the remainder is added. Okay, remove the last digit from the original number. So how to remove the last digit? X divided, so as to remove the last digit of the number, and apply the original sign to the reverse number. So you have to apply the original sign, re reversed x, size sign multiplied with the sign, and the sign will be same, and apply the original sign to the reverse number. If it is in negative, then you have to also return that in negative. And to check if the reverse number is within the 32-bit range, you can do that. To check if it's between the 32-bit sign integer range, if reversed int min or reversed x greater than int Then what to do? Then we have to return 0. That if it overflows, that it's not in between that, so it overflows and return the valid reverse string. So we have to return the reversed string. Reverse x is returned. This one is returned. And so let's try it once. Let's see if we have done any mistakes. Let's see. Okay, so here is the problem. So syntax error is in this code. That is invalid syntax, right? So what's the problem in it? Remove the last digit from the original number. We might have done it 2 times. Let's see if it works. Maybe. No, it doesn't. Let's try again. So here I changed some indentation because the indentation was wrong. So I fixed the indentation and this one was also wrong. This position of it, which was like this was not there and the space in between them was an error. And if the space is there, then it will cause an error. So I just fixed this. And the indentation of this reversed x was changed to this sign. And then if I run it, then it's accepted. Let's hope. Okay. So it's accepted and let's submit it. Beats just 5% because it's in Python and most of the users are using Python. One question done. Let's do the second question. This one is done. Done. Second question, add binary. We have to do 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions today. Let's move on. In between, understand the question, what's written, add binary. Given two binary strings, and what we have to do is we have to input the binary string input 11 and b1, then the output will be 100. So that represents that the binary string is returned. Okay, so understanding the question, I found out that we have to return, given two binary strings A and B, return their sum as a binary string. So the 11 plus 1, that is 12, on the output comes as 100. So these are the binary strings and return the sum as a binary string. 1010, then 1011, then it comes out as 10101. So the constants are also given. Let's do it. Let's try doing it. If it's right, then if it's right, then it's okay. But if it's not right, then we'll try because we don't know giving up. We'll try till it's right. So this is all initializing the result string and carrying it, and then will be as it's a string. So we have to return the string. Result is null right now. So carry will be 0. Pointers to traverse both the strings. We have to use the pointers I and j, and which is equal to length of a minus 1 comma length of b minus 1. Okay, so we have to loop until both the strings are exhausted or there is a carry. While I greater than equals to 0 or way greater than equals to 0 or carry, then what to do? Get out of the current digit of a or 0 if out of bound. Digit a equals to int ai. If I greater than equals to 0 else 0. Get out of the current digit of B or 0 if outer bound. Similarly, what to do for B? Let's copy it and paste it. Here it's B and it's J. We use two pointers here, I and J. And this is it, the while loop. Then calculate the sum of it. Calculating the sum of it, we have like we will add it all, digit A, digit B and carry. And then we have to update the carry if 1, if total is 2 or 3, otherwise it will be 0. Carry will be equal to total divided by 2, add the current bit to the result 0 or 1, result equals to string total models 2 plus result. Move to the next digits, I minus equals to 1, j minus equals to 1, return the resulting binary string, return the result. Let's see if it works. If not, then we'll try again. Let's see if the indentation is right. Indentation is the holy grail here because in Python, indentation matters. Indentation matters a lot. Let's first of all run it, then we'll get the code. If there are some errors, then we can catch it. Okay, so there is wrong answer. If there is some wrong answer, then why? Maybe because of indentation. It's because of indentation. It is it result, then carry pointers while digit total. Okay, then carry result. Okay, it seems to be correct, but doesn't seem to be correct. I will try again and check if the indentation is right or wrong. Let's see. Well, now I fixed the indentation and some of the spacings between them. The right spacing would be this one and this one should be the space between them. And previously it was not working, but now it will work. Let's see. Accepted. And the problem previously was like the space was not quite adequate in between them. The space was quite smaller. So this was the error. Let's see. It will give the wrong answer. No, it's accepted. So maybe this one was the problem, the divide sign. Or like the initialization of it was the real problem of it. Yeah. So the initialization of I and j should be correctly done, and the digits when carried, the results and all the operations performed should be well indented. My issue was I had the return here, so at that point it was giving wrong answers. Yeah, this was the wrong answer. And here it was giving, okay, let's try again. And at this moment, it's accepted. Okay, submit it. Moving on to the next question. Okay, so the next question is the palindrome number. Number. Let's do it. Understand the question. In between, understand the question. What does it try to show? Given an integer x, we have to give that. If so, given an integer x, return true if x is a palindrome and false if it's not a palindrome. So palindrome is a string which, when reversed, is the same string. It returns the same string when reversed. How to do it? There is an input 1 to 1. Reversing 1 to 1 would read 1 to 1. So this is similar to all the questions that we did. Okay, so let's start. We have the code with us. The code is okay. So the input would be this, and this one is false because negative is not considered and it's not a reverse of itself. How to do this? True or false is to be returned. So palindrome is given. Def palindrome negative numbers are multiples of 10 except 0 cannot be palindromes. If x less than 0, then we have to return straight away and false. Or if x is divisible by 10 and x is not equal to 0, then return false. Original is x. Store the original number, that is original is x. Reverse half will be 0. This will store the reverse half of the number. So while x greater than, so while x is greater than, extract the last digit and build the reverse half. It will remove the last digit. Check if the original number is equal to the reverse half or if reverse half is the reverse half of the number. Okay, so this one is returning it, but let's see how it works. Int object is not callable. I will try to fix the issues. Okay, so this one is and this one is, there should be a space between them. Line number 4, 30 and 41. Okay, so it should be in capital, right? 4 is fixed, 30. Oh, that is a driver solution. Okay, so it's accepted. Kudos to us. Initial check, that is the negative numbers. These are not palindromes by definition, and since the negative sign will not be mirrored, so we don't consider them to be negative numbers and not considered to be palindromes. So here it's figured out and it's flushed out. If x is less than 0 or x is divisible by 10 or x is not equal to 0, then return false, that it's not in reverse of any number, that it's not a palindrome. Original is x and then reversed half is 0, initialized to 0. While x is greater than reversed half, then reversed half equals to reversed half multiplied by 10. 0 multiplied by 10 is 0 plus x division by 10 and the remainder is stored into it. So here it is. This divided by 10, that is the remainder. If the number is 1 to 3, then if divided by 10, it will return 3. The reversed half will be 3. Now x is divided by 10. As x is divided by 10, now the value will be 1, 2. Not 1, 2, 3, it will be 1, 2. So 1, 2 is the new value. Then 12 divided by 10 returns 2, then 3, 2, and then it returns another time. The loop will go 1, 3, 2, 1. That's the reverse of 1, 2, 3. Simple, right? So that's all about the code and it's accepted. Let's submit it. And kudos to us. We did another question. Easy peasy, right? It beats 27.38% of the users. Moving on to the next question. Here it is, minimum moves to equal array elements. Let's spend some good amount of time in understanding the question, because once we understand the question, then it's cakewalk to do it, and it's quite easy to figure it out how to do it. Okay, so minimum moves to an array. Minimum moves to an array, equal array of elements. Okay, so minimum moves, it is question number 453. How to do it? Figuring it out. Given the integer nums of size n, return the minimum number of moves required. Okay, to make all the arrays elements equal. So in one move we can increment n minus 1 elements by array of 1. Then how to do it? Understanding the problem. In one move you can increment n minus 1 elements by 1. This is equivalent to decrementing just one element by 1 when viewed in context of making all elements equal. Optimal strategy. So what will be the optimal strategy? To minimize the number of moves, you should reduce all elements to the smallest value in the array, and this is because decreasing one element at a time to the smallest value will minimize the total number of moves required. And the steps will be find the minimum value in the array, compute the total number of moves needed by summing the differences between each element and this minimum value. Okay, so a simple Python code, that is how to do it, and let's start. So find the minimum value of it, mean moves and nums, and total number of moves required. It will calculate moves equals to sum of num minus inval. Simple code, right? Let's see if it works. Hope so. Okay, it's accepted. So what we did here? Find the minimum number. So using min function to find the smallest element in the array, using min, so we found the smallest element in the array, min val. So we found the smallest element in the array and then calculate the moves. Iterate through each element in the array, compute the difference between the elements and the minimum value and sum these differences. We will traverse, iterate through each element in the array. compute difference between the elements and minimum value and sum this as the difference. The sum of these differences gives the minimum number of moves required, and the time complexity of it will be O of n, where n is the number of elements in the array, and this is due to the single pass required to find the minimum value and another pass to calculate the sum of differences. So this will be the sum of differences, and this one is the minimum value O of n and O of n. So it will be overall O of n. Space complexity will be O of 1, as we are using only a few extra variables. This solution is efficient and works well within the constants provided, and this works within the constants, that is n equals to num's length and 1 less than equals to num's length, and it's not greater than 10 to the power 5, and 10 to the power minus 9 is less than equals to num's and not greater than equals to 10 to the power 9. Okay, so that's all. And this one about the question, let's submit it. Pretty much good, right? So it's submitted and accepted. Moving on to the next question, beats 88.30% of the people. Quite good, right? Happy. So happy number question. Let's see if we can do it. Happy number question. Okay, so let's try it. The happy number question. Read the question. First of all, it's essential to read the question, because if you read the question, then the half of the question is solved. Half of the question is solved as you know how to do it. If you know how to do it, a happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of the digits. Okay, sum of the squares of the digit are given, and repeat the process until number equals to 1, where it will say or it loops endlessly in a cycle. Does not include 1. Those numbers for which the cycle ends 1, and happy input n equals to 19 true, explanation 1 square plus 9 square equals to 82. Okay, so this one is like this input n equals to 2 false. Yeah. So this one is the question, and how to do it. To determine if the number is happy number, you can use a method that detects cycles in the sequence of numbers generated by repeatedly replacing the number with the sum of the squares of its digits. If a cycle is detected that does not include 1, the number is not happy. Sum of the squares function. So define a function that computes the sum of the squares of a digit of the digits of a number. Cycle detection using is set to keep track of the numbers that may have been seen. If you encounter a number that has been seen before a cycle exists and the number is not happy, check for happiness. Continue applying the sum of squares function until the number becomes 1, indicating happiness. So we have to do decrement operation here. How to do it? Let's start. So here it is, the Boolean function to return if it is true or false, calculate it, and the total. Calculate the sum of the squares of the digits, and total is assigned initialized to 0. Okay, so while num is greater than 0, digit equals to the remainder of num and 10. Total equals to the sum of digit, square of digit. Okay, so digit into digit is the square, and num is then divided by 10. It's like reversing the number. Returning the total. Okay, so if it's seen, we have to track it that it's seen or not. And it's not equal to 1. I can add 10. If we end up with 1, then it's a happy number. If not, it's not happy. Let's try the code. Let's see. Hope for the best. Error is there. Return outside the function. Let's try it again. Well, here is the updated version. So I forgot to add the get sum of squares, and the indentation was also wrong. Run it. Accepted. Okay. I tried updating n with the sum of the squares of the digit until it requires no further addition and it equals to 1, indicating it's a happy number or until the cycle is detected. Time complexity of it. So time complexity of it, the approach typically converges equally. It converges quickly since okay, it beats 63.48% of the users, quite good, and tends to enter the cycle that are detected efficiently. The practice it is close to O of log n, where n is the number of digits in the number, and space complexity is 1 by log n. Okay, due to the set of storing previously seen numbers. The solution efficiently checks if a number is happy and avoids infinite loops by using cycle detection. That's it. That's the code. That's all what we did here. Next code, Excel sheet column title. Understand the question, what it says. Given an integer column number, one return its corresponding column title as it appears in an Excel sheet. But we return the number as it appears on the Excel sheet. How to do it? Let's try. Excel columns are basically represented as A to 1, B to 2, and likewise for the 26 digits, the 26 alphabets, and double A as 27, AB as 28, and this goes on further. So how to convert? Conversion process will be while converting, adjust for 1 based indexing by subtracting 1 from this column number. Before computing the remainder, use the modulus and division operations to get each character. Reverse the result so that since the least significant digit is computed first, rightmost, and the resulting characters are corrected in reverse order. Let's do it. Suppose the title is initialized to null. Null. So while column number greater than 0, okay, then computing the current character and prepend it to the title. As 26 alphabets are there. Let's see how can we solve it. So this was an issue of indentation. Let's try. Okay, so still it's showing an error. Return outside the function. Okay, return outside the function. Now I try to correct it once again. Let's see if it runs or not. Hope so. Accepted, right? So the indentation was wrong. Like this one was this side, this one was this side. I corrected that. Let's submit. Basically, what it does is adjusting the negative number, and the time complexity of it is log of 26 n, where n is the column number and number of iterations is proportional to the number of digits, that is base 26 representation. Log 26 space complexity will be of log 26, that is base 26, for storing the characters in n. It will be multiplied with n, so log 26 into n. This approach efficiently converts a column number to the corresponding Excel column title. What it does, column number, that is here, it converts the self column number integer to string, and then how it does, 1 to a, 2 to b, title is 0 initialized, empty, while column number is greater than 0, column number minus equals to 1, column number is deducted, that is it starts from the end, title appended, character, column number, if modulus with 26, that is the remainder, plus ord, ordinance of a, that is converts the index to the corresponding character, and column number divided by 26, it will return the joint reverse title. That's all about it. Next question. Missing number. Okay, let's try. What it says, Leetcode 268. Leetcode 268 says that how to find the missing number. Array nums contains n distinct elements in the range 0 to n, and return the only number in the range that is missing from the array. Okay, so we have to return that. How to do it? Input is nums 301, on the output is 2. That is n equals to 3, since there are 3 numbers, all numbers in the range of 0 to 3. 2 is the missing number in the range since it does not appear in the nums. So in the range what is missing, we have to return that. How to do it? And the simple solution, the logic behind that is, to find the missing number, we have to find the sum formula. We have to use the sum formula. That is, the sum of the first n natural numbers can be calculated using the formula, like the sum and divided by the fraction n times of n plus 1, and n into n plus 1, that was the formula, I guess. And by calculating the expected sum from the numbers 0 to n and subtracting the sum of the elements in the array, the difference will be the missing number. Subtraction, the actual sum of the numbers in the array from the expected sum to get missing number. So the total sum will be calculated by subtracting the sum of n natural numbers from that. How to do it? Let's see. It's kind of easy, and easy questions. List is that n equals to length of nums. This is the length of the nums. Calculating the expected sum of the numbers from 0 to 1. Expected sum will be equals to n into n plus 1 divided by 2. Like the Python convention, it is divided by 2 sum equals to sum of nums. The missing number is difference between the expected and actual sum. Return expected sum minus actual sum. Let's see if it works. Accepted, right? So it's quite simple, right? We found out the sum of n natural numbers. Expected sum is assigned to that n into n plus 1 divided by 2. Actual sum is sum of nums, that is in the list of the integers. Then we return the number missing, that is the expected sum minus actual sum. That's all about the question. Moving on to the next question. Product of three numbers. How to find the product of three numbers? Product of three numbers. Maximum product of three numbers. How to do it? 1 to 3 is given, and we have to find the maximum product, that is not the least common multiple, that's not the LCM, that's the else HLM, that is highest common multiple, HCM. Okay, HCM will be fine if you tell it like highest common multiple of it. Maximum product of three numbers. What will be the maximum product of the three numbers? 1 to 3, 1 to 3 into 4. So 2 into 3 is 6, and 6 multiplied with 4 is this. How can you do it? By sorting the array in non-decreasing order. We have to sort the array in non-decreasing order, and then the maximum product can be product of either the three largest number which are at the end of the sorted array, or the two smallest number, most negative number, and the largest number, since multiplying two negative numbers results in a positive number. So selecting the maximum, comparing the product of the three largest numbers with the product of the two smallest numbers and the largest numbers, and returning the larger value. So how to do this? Let's code, try it. So we have to sort it. The nums should be sorted. Define maximum product self nums list int. Okay, nums dot sort now sorted. And then option one is we have to find the product of the three largest numbers, maximum largest numbers. Okay, max one is nums minus one into nums minus two into nums minus three. Option two is product of the two smallest numbers and the largest number. Max two is nums at the index 0, nums at index 1, nums at index 2. Okay, so the product is found out in max 2. The result is the maximum of the two options, that is return the max. Simple, isn't it? It is indexed and it's accepted. Fine. Let's submit it. It's kind of easy question, that is define the sum. Okay, why it is the wrong answer? Why it is the wrong answer? Output 24, expected 3920. So this is the solution of it, but why did we do something wrong? Num sort, and why did we do something wrong? I hope it's fine. Submitted. Still the same. Okay. So 69 of the 93 test cases passed, and this test cases is not passed. Okay. Uh, how to pass it? Here the time complexity was n by log n due to sorting step and O of 1 if the sorting is done in place, and otherwise it's O of 1. It's the optimized approach, and the time complexity will be O of n, and changing the code it will be quite bigger. So let's leave it. This is the logic and this is accepted, and we know that we did something right, and move on to the next question. Power of 2. Ignore the question because here we are having the wrong answer, but the logic is correct. Maybe we are not meeting certain test cases. The test cases are to be met. Given an integer n, return true if it's power of two numbers, otherwise false. If it's a power of two numbers, that is 2 to the power something, then it's true, otherwise it's false. How to do it? Input n equals to 1, true because 2 to the power 0 equals 1, n equals to 16, true, 2 to the power 4, 16. I guess we might use log here. Using loops or recursion, follow-up is given. Okay, we have to do it by binary properties that a number is a power of 2 has exactly one bit set in its binary representation. For example, 1 in binary is 001, 2 is 0010, 4 in binary is 0100. If n is a power of 2, then n and n minus 1 will have no bits in common. For example, 4 is 0100 and 3 is 0011. That is, they are not sharing any set of bits. Therefore, n and n minus 1 should be 0 if n is a power of 2. N must be greater than 0 because non-positive numbers cannot be powers of 2. How to do it? It's just simple one line of code. Check if n is positive and binary property holds. Return n greater than 0 if n is greater than 0 and if n and n minus 1 equals to 0. Check it. Accepted, right? What it does. The time complexity of this is O of 1, the simple one line of code, and space complexity is 1 O of 1, that is no additional space is used. Since the operations performed bitwise and in comparison are constant time operations, so the solution is efficient and it handles all the edge cases, ensuring it passes all the test cases. How it does? What is the explanation of this code? The expressions n and n minus 1 checks if n is a power of 2. N is greater than 0 and n minus 1 is equals to 0. So I have it here. N is greater than 0 ensures that n is positive and negative numbers and 0 cannot be powers of 2. Return n equals to 0 and n minus 1 equals to 0. That's all. This was the solution. And I hope today we have solved all the 9 questions of here 1, 2, 3, 4, 5, 6, that is from 55 to 63, 9 questions. Solved it. I hope you enjoyed the session. We'll see you in the next video. We'll solve the medium questions and then the hard questions of this. 66 to 72, like 6 questions, and the hard questions are 4 of them. 10 questions in total of math section. We'll solve it in the next session. Till then, goodbye.